Good afternoon and welcome to NASA's Johnson Space Center for today's mission status briefing. This is Flight Day 8 of the STS-132 Space Shuttle mission to the International Space Station, and the crew on board the Space Shuttle and Space Station complex just completed the third spacewalk of the mission, so we'll outline those activities. And to do that, we have the lead Space Station flight director for this flight, Emily Nelson, as well as the lead spacewalk officer for the flight, Lisa Shore. And Kirk Shireman is joining us from the International Space Station program. He's the deputy manager to give a look ahead for the program activities following this flight. And I'll turn it over to Emily for opening comments, and then we'll take questions.
Thanks. Well, today was another great day to be involved in the manned space flight program. Another fabulously successful EVA. We headed out the door about 30 minutes early, completed all of our scheduled tasks and some additional tasks that we added in just before the flight. Started out with a jumper installation out on the truss that finishes up some connections for our ammonia systems outboard. Then finished the final 2 battery swaps for the 6 batteries that we brought up on the ICC VLD. Then tucked in some thermal blankets that we had neglected to tuck in on EVA-1. Went ahead and took care of that real quick on our way back towards the payload bay, where we grabbed a grapple fixture that we brought inside to reconfigure for use later. Meanwhile, inside, Soichi has fixed the potable water dispenser, so the ISS crew has hot water at their disposal again. And in MRM-1, in terms of a status for that module, yesterday the Russian crew ingressed the module. They've put in an air filter. They did find some metal shavings inside. So after having filtered the air and taken initial air samples, they also installed some clamps, getting the physical mate between the module and the station finalized. They closed the module overnight to let the filters do their thing and try to capture those metal shavings. They took another look at it this morning. It was looking much better, fewer shavings, although there were still some there. So they opened up a couple of panels that increased the ventilation and the access, basically, of the cabin air to those filters. And they'll be taking another look at it in the morning, and we hope by then it'll be all cleaned up and we can integrate the air in that module with the air in the rest of the station. So we're making progress there as well. Meanwhile, the crew's been organizing the cargo inside the module so we can unload it quickly after the mission. Tomorrow, Piers and Garrett will be using the station robotic arm to put the ICC back in the payload bay. And then the crew will be working mostly on science and transfer, and then the shuttle crew will have a little bit of time off in the afternoon. And the mission management team yesterday decided that we do not require any further inspections during the docked mission, so those will not be added to tomorrow's mission. We'll just keep our late inspection in the timeline as we had it pre-mission. And that's pretty much our summary at this point. You want to go over the EVAs?
Oh, sure, I'd love to. Before I jump into the EVAs, I'd like to say happy birthday to my dad. I wish I could have been there, but I was a little busy today. Watching over our wildly successful third EVA of this mission. I'll just start by saying I just couldn't be happier by how this crew has performed. We had our third team go out today with Mike Bueno as our lead for this EVA with Garrett Reisman. Like I said, just performed flawlessly, great teamwork throughout the entire EVA. As Emily stated, we started out the EVA by doing a get-ahead task, short get-ahead. That was the ammonia jumper. We decided to have the crew do it up front while they were unburdened with their tool bags that we had stowed out on the truss between the EVAs. Once we completed that, we proceeded on out to the P6 truss, and the crew jumped right into the battery R&Rs. Started out by releasing that temporary stowed battery that we had put into a safe tethered position between the EVAs, released that tether, locked it back down out of the truss where it would be out of the way of the robotics operations, and then proceeded to have Garrett jump into the foot restraint and start removing the first battery from the truss. And went just as smooth. The crew obviously passed on the information that Mike and Bueno had learned from EVA-2, and the battery removals and the installation into the pallet every time went really, really well. We're very happy with that. We then performed all of our cleanup that we had hoped to get done. So we brought in our tool bags, one of the foot restraints that had been out on the P6 truss since the STS-127 mission, and then also the gap spanners, which are the tethers that run the length of the front of the truss there. We brought 4 of those gap spanners in 2 chains back inside. Once we got inside of the solar array rotary joints, we stowed one of those foot restraints. We also took care of a flap on the EOTP thermal protection that was on the side there. The payload owners noticed a little piece of material that hadn't been Velcroed down, so we took care of that. We also troubleshot the foot restraint that we use for the cable repair of the laser system on EVA-2. Steve had reported that the pitch joint on that swing arm on the CETA cart that we have there was frozen, and indeed we went back there to see if we could get it to move, and it is indeed still frozen, so we will deal with that issue at a later time. We proceeded inboard at that point. The crew dropped off the bags they were carrying so they would have their hands free when we got down into the payload bay. And Garrett and Mike worked together to release the grapple fixture from the side of the payload bay that we had brought up. That entailed installing a fixture onto there that let them mount the grapple fixture onto their body restraint tether when they left the work site. Went just like we trained it in the pool. They handed off their tools back and forth to accomplish the release. And then Garrett did an excellent job kind of shepherding the grapple fixture from behind as Bueno carried that back towards the airlock. Once they had the grapple fixture stowed in the airlock, which took a little bit of doing because it is quite large, about 1.5 feet in diameter, we had a little bit of time left in our planned EVA, so we gave them the go-ahead to grab the bag of tools and headed out to the Z1 truss to our toolboxes over there, and we're able to stow, I believe, around 4 tools back into that toolbox, and we also retrieved a tool board that we needed to change out some sockets in our torque multiplier tool for use inside. Once that was complete, it was time to come back inside, and guys climbed back in, no difficulty, and it was just the end of a great EVA, and like I said, the end of just a great, great mission. We accomplished more in our AVAs than we ever could have hoped for, and really proud of how the guys did. And that's all I have. I'll hand it over to Kurt.
All right, good afternoon. It's a pleasure to be here and talk to you about the International Space Station. With a new module, new batteries, a new comm antenna, a new platform for Dexter. We've had a great mission so far, and we're really excited. I know that sounds a little redundant, but that's very true. We're all very happy about how things are going. The shuttle crew and the ISS crew have performed exceptionally well, as have both the shuttle and the ISS vehicle. So we're very, very pleased with how things are going. Of course, we have to finish the transfers and then undock and get the shuttle home safely. But we're well on our way, and again, it's been a great mission. I just want to talk to you a few minutes about upcoming events on ISS. So while we're getting the ISS great shape here, the last part of the mission, we still have some activities coming up very quickly. First, the 21st Soyuz will be undocking on the June 2nd and bringing Kotov, Noguchi, and Kramer home to Kazakhstan, to the southern landing site. So we're very much looking forward to having that crew back on the ground. And then followed quickly by the 23 Soyuz launch. And that'll happen on the 14th of June and docking on the 16th of June. In fact, early next week, we'll be having our flight readiness review for that, for the landing and for the launch of the Soyuz. Shortly after the Soyuz arrives on orbit on the 16th, we'll actually go and relocate that Soyuz from its location to the new docking port on the MRM module, and that'll happen on the 27th of June. So again, lots of activities here in June. And then to close out the month, we have a Progress that'll launch on the 28th. So even though the last month has been very busy for the ISS crew with 2 shuttle flights, we still have 1 more month of vehicles coming and going, and things should then settle down for a good summer of research. We also have a Russian stage EVA and a NASA, a U.S. stage EVA planned sometime this summer. So, but we'll be focusing mostly on research. September will bring the flight of UL-5. It's currently scheduled for September, and we'll be bringing up on that flight. We'll bring up another permanent module, a permanent multipurpose module. We call it PMM, manufactured in Italy. It's actually a multipurpose, an MPLM that has been modified to stay on orbit long duration. And we'll also be bringing up one of our large radiators, a spare unit that'll fly on a external pallet. And then lastly, here later this month, we're looking forward to the launch of the first SpaceX Dragon vehicle. I'm told they announced, I think today, that would be the 27th, no earlier than the 27th of May. So we're looking forward to that. While that vehicle itself is not going to ISS, it is one of the flights that are leading up to delivering cargo to the ISS next year. So we're looking forward to a successful flight for our SpaceX friends. And with that, I'll hand it back to Kylie.
Okay, we'll start with questions here at the Johnson Space Center. Go ahead.
Thank you, Mark Carreau, for Aviation Week. I wondered about the batteries that you installed this week. Have they been tested? Are they charged and recharged? And do you know if you actually got the performance, or can you explain how you'll determine whether you have the performance you were hoping for?
Certainly. We began charging the first pair of batteries after the second EVA once the first pair was completed. And those are fully charged and back in the system and operating exactly as we expected. Tonight, actually before we even finished the EVA, our power officers began charging the other two sets of batteries, and so by tomorrow morning I expect those will be fully charged and ready to go. In terms of whether they're performing at the capacity that we expect, that'll require some charge-discharge cycles, so it'll be a little while before we fully characterize their performance. But so far, they're looking great.
And Mark, if I could add something to the batteries. The original batteries were launched in November of 2000, and they had a design life of 6 years. And so here we are 9.5 years later, and the batteries that were on board were still performing within their specification. Obviously, there's been degradation over the years, and the way their performance is, hits basically the knee in the curve, and it really drops off. So it was definitely time to replace the old batteries with these new batteries, and these are very new batteries. So while we're happy to have the new ones up there, same design as the original ones, we expect those batteries to perform equally as well as the original batteries in that truss element.
And just to follow then, so the design life might be for the new ones the same, 5.5 years, I think it's been mentioned, but the actual experience is closer to 10, and that's kind of what you're expecting.
Sure, and a lot of factors play into that. Of course, there's how the battery, we call it how the batteries are treated, but really it has to do with the stowage conditions on the batteries before they're launched. So they're charged, basically. These are nickel hydrogen batteries, but the cells, individual cells, are actually charged, and then how the batteries are maintained on the ground. Typically, we keep them in a freezer, frozen. It keeps parasitic chemical reactions from taking away a life from the batteries. And then it has to do with the depth of discharge. So the batteries are charged every pass when the solar rays are collecting light in the sun. They're charged up, and then when we go into the eclipse period, they'll discharge. And certainly when we have to be in attitudes like for dockings or undockings, the batteries may drain down to a lower level. As long as we operate in the higher, or I'll say low depths of discharge, we operate from 100, say, down to 80% of charge of the batteries, their life tends to last very long. And so our expectation is these batteries will last at least as long as the original ones.
Bill Harwood, CBS, and I apologize if I missed this because I was typing something. What is the next set that has to be replaced, and approximately when?
Well, that's a good question. I can tell you our next set of batteries we're bringing up on an HTV, and I believe I want to say HTV4. So I tell you what, let me get back to you on the specific answer. But it's on it that we're going to launch them on an HTV after the shuttle has retired. And it would be, I think the next set is on the, on the inboard side, on the port side. But I'll get back to you and answer specifically. It's been a while since I reviewed that data.
Hi, Robert Perlin with CollectSpace.com. What was it about the about the grapple fixture that it needed to come back inside first and not be transferred directly to Zarya? And when is that installation now targeted to occur?
It needs an adapter in order to be installed on the external interfaces there on Zarya, and it's tentatively planned for one of the U.S. EVAs this summer.
Philip Sloss with NASASpaceflight.com for Mr. Sharman. Regarding the ULF-5 mission, I understand that the content and the payload are in some flux. When do you expect to make a decision on, for instance, EVAs perhaps being added and any payload changes?
Well, let's see. The major payloads are fixed. We have a carrier with ORUs, the biggest of which is this radiator, and we have the PMM, the Permanent Multipurpose Module, which is that modified MPLM. So that the major elements are fixed. The specific cargo elements in the PMM is somewhat in flux, and that's very normal for us. And we'll bring 6,000 pounds of cargo items up in an MPLM, and so it's normal that we'll maximize the amount of cargo we bring up inside, and maybe change out a set of towels for something else, or maybe it's one payload for another. That's just normal business as we go on and see how the hardware is being developed. Most of the hardware that's going to fly in the PMM, inside the PMM, is currently still being developed. It's in its manufacturing cycle, so we have to watch how all that plays out. So what I'd tell you is the major elements of that mission are cargo, from a cargo standpoint, are defined. It's just, I'll say, small trades. One of the things we're launching on that, by the way, is Robonaut 2. I think you've probably heard about that. That item will be launched in there. We're also launching an experiment. It's called cameras, but it's really a device to take carbon dioxide out of the atmosphere, and it's a device that was really being developed for the long duration space flight to the moon or Mars. And so our plan is to launch a device like a development unit for that and test it out on board ISS. You asked about EVAs. We have talked about it in the Space Station Control Board actually this week with the intent to add up to 2 EVAs on that flight. It hasn't been approved all the way through, and we haven't finished the definition of the content for those. So I think you can expect to hear officially that we'll do 1 or 2 EVAs on that flight, and we just have to work out the details. And if I could, I'd like to explain why. Previously, ULF-5 was the last flight. And we were flying it with a minimal crew because we wanted to maximize the amount of cargo we could get on that flight. And we want to leave the ISS with our external high-pressure gas tanks to the max full. And so in the process, but between when we initially defined that flight and today, we've added a crew member, which added more capability for that flight. And now we swapped the order of flights. We have a whole host of EVA tasks that need to be accomplished that weren't assigned to a specific EVA. And so now it's our opportunity to go capture those tasks, because after the shuttle stops flying, we go for a period of 2+ years where we are unable to repressurize our external gas tanks, which means every EVA is taking away that pressure, and we basically can't do another EVA or can't replenish that source until we get a new device that we're manufacturing up there to replenish those tanks. So we want to take every opportunity to do spacewalks and finish all the tasks that we can before the shuttle retires, and then the last flight leaves our tanks as full as they can get.
There's one more question here.
Peter Aylward, Southern FM in Australia. A question for Mr. Sharman. Is there any allocation of the crew, the ISS crew or the shuttle crew's time for observation of the oil leak in the Gulf to be planned?
So we don't have specific, right now I'm not aware of a specific, it would be a payload operation or experiment to go take photography of the oil leak. So I'll say it's not a booked time that says yes, to perform research you will take a photo every time we fly over the oil spill. Now, having said that, there's time available in a crew member's day to do Earth observation as they choose. And I'll tell you, I typically see if not every day, at least every other day, a new photo of the oil slick taken from space. So I'll just answer your question. It's not an official task, but it's actually being done, and those photographs are available here on Earth, and I believe they're being passed around to the various entities that would be interested in tracking how that oil spill is migrating.
Is that adding anything different to what other assets like satellites and things? Is there anything unique about what they're doing, or just adds to the
I understand your question, and unfortunately I'm not in a position to answer that. We can supply the photographs, but as far as how that fits with other assets tracking the oil, that's really maybe a question more for the Interior Department or British Petroleum.
I can add to that a little bit. We've discussed those pictures that have been taken by the station crew, and one description described that the astronauts can see the water at a different view than the satellites take, from a direct view to the water. So there are different glints, sun glints, and different, but how that affects the analysis, I don't know. We'll go ahead and go to questions on the line. First is Marcia Dunn.
Yes, hi. I have a few questions for Kirk. I'm wondering, it sounds like the Russian module is now closed, and I'm just wondering, is that my understanding correctly? And have you heard from your Russian counterparts what might have happened to cause all of those filings to be floating around?
Well, let me first say that it's not unusual at all to have debris inside a new module. In fact, it's not unusual to have debris in any module that comes up. So, for instance, when we fly an MPLM up to ISS, even though it's been there a number of times, we still require the crew to wear protective equipment. They wear goggles and they wear a mask when they go in. Because on Earth, all that debris sits down in the bottom, I'll say in the floor, but it can get nooks and crannies in racks and behind cables, and it's all great until you shake everything when you launch, and then you get in space where it just floats around. So it's normal to have some amount of debris. In a new module, it's actually normal to have some minor amount of metal debris. We've had it in a number of, we had it in Node 1, we had it in Node 2, we've had it in Node 3, we probably had it in other modules too. So all this is relatively normal, and dealing with it is just what we're doing now. The crew wears protective equipment. We actually run the ventilation for a number of hours, and we have a flight rule. Emily could probably tell you what the flight rule says, but a number of hours to go try to have the debris migrate to the filters, just like we're doing. It turns out the MRM-1 is filled with cargo. So that module was filled with 1.4 metric tons of actually U.S. cargo when it was launched. And so the airflow is not optimum. In fact, that's what this task was that they were doing during the mission, is to go remove some of those things and improve the airflow, which we have done. So even though you're hearing about it, I would just say it's really not that unusual, and we've taken measures to protect the crew, and we believe, as do our Russian colleagues, that given a little time, that debris will all migrate to the filters, and we'll clean it up with a vacuum cleaner and move on with the module's life.
Have you heard from them, though? Are they saying that this is just basic manufacturing filings that are coming to light?
Yeah, I haven't heard them say that. They haven't said that directly, at least not when I have been present. But like I said, that's our experience, and I say ours, meaning not just the United States. That's the experience with the modules that were manufactured in Europe and Japan, and that's just normal manufacturing experience.
And two more questions, the first of which is, how much did they have to unload to get to those panels, and when do they really expect to unload the whole thing?
And let's see, Emily, you can ask maybe the first one, or you're absolutely welcome to both of them, but if not, I'll take the second one.
I haven't heard directly how many of the panels they've removed in order to get back to the panels I referred to for the ventilation, but indirectly, based on the questions they've asked about what would we like them to activate and not activate, I can tell you that I'm pretty sure they've made it all the way to the bottom of the module at this point. But the cargo is still inside, so they're really just kind of rearranging everything and getting the launch racks that I talked about a couple of days ago that all of the cargo was attached to for the ride into orbit. They've gotten those out and kind of pushed the cargo off to the side so that they could get access to whatever they need to in order to improve this ventilation and get the air nice and clean. In terms of when they intend to unload, I can tell you that the crew is anxious to get the module unloaded, and so if we don't provide them a plan to get it unloaded the week after undock, I think they'll start without us. So I think we'll be getting that started shortly after this mission is finished.
And our requirement to have it unloaded is before we relocate the Soyuz on the 22nd of June. So we expect to have it for sure in ship shape by that time.
My final question for you, Kirk, is you mentioned a new crew member for the next flight. Who is that? I hadn't heard.
Well, it was a long time ago. So this is when we were initially defining the mission, and we were looking about how we do rescue flights. So this is not a recent thing. In fact, it's probably before we even announced the crew. So I'd really prefer not to name any specific names. In fact, to be honest, I don't even know the name. I just know we talked about having initially a crew of 5. I think initially a crew of 5, and we decided to go to a crew of 6. So all this happened, I think, even before we named a crew.
Oh, okay. I thought maybe there was yet another 7th crew member coming on board.
No, we haven't done that, and really don't intend to, because we want to have enough crew members to do the job that we have to do, but we also want to maximize the upmass. And really, on ULF-5, we'll have the PMM, but upmass and downmass, by the way. But for both flights, we'll only have a mid-deck returning, and we, as you know, we try to remove certainly all the payload and samples that need to come home to the ground, but also any items that are no longer required on ISS we'd like to bring home. So we want to maximize the amount of cargo we can bring home on those flights, and it would be a trade between additional crew members and up and down mass. And we believe at this point in time we have optimized that trade with the crew complement that we have.
Okay, next on the line, Tarek Malik, do you have a question?
Thank you. Yes, it's Tarek Malik with Space.com. I think I have a couple of questions for Kirk and for Emily. For Kirk, with I guess the major bulk of the maintenance and construction complete with the spacewalks on the flight, I'm wondering if you can kind of give us an idea of percentage-wise how complete the station is now, maybe what's remaining, and how robust it is given the new module.
Well, let's see. I can't quote you the percentage. Maybe Kylie might have an idea from some of the materials we put out. But from a pressurized module standpoint, we have one more module we're going to launch from ISS, which is the PMM on ULF-5, the next flight. We have 2 external carriers we're going to fly. We're going to fly one on that flight, ULF-5. We have another carrier that'll fly on ULF-6, and then a massive payload, AMS, that'll also fly on ULF-6. So from a mass standpoint, we're very, very close, probably 90, 95%, and I can get the exact number. I'll try to do that for you. But in terms of robustness, we look at overall system robustness, and from a power and a thermal and avionics and from a life support and even from a docking resupply standpoint, we're in excellent shape. And with this new module now, we have 4 docking ports from the Russian side. We're in outstanding shape. We're in the robust configuration that we expect to be in for a long time. So we're very, very happy to be in this configuration. And of course, our goal was to be in this configuration and then have the additional spares that we're going to launch on these last few flights to put us in a position after shuttle retirement to fly through 2020, and we'll be there.
To answer that question, I do have for the volume of the space station 98% complete habitable volume, 94% complete in the total pressurized volume. I don't have the percentage for mass, though.
Thank you.
Thank you. And for Emily, you mentioned that there's some time off coming tomorrow for the shuttle crew, and given, I guess, a busy week of spacewalks, I'm wondering if you're going to have to give them some extra encouragement to make sure that they rest up before undocking on Sunday. And then just a quick follow-up, I'm just wondering when you might need to see the cart that seems stuck in the near future to move that. So that's it. Thank you.
In terms of off-duty day, we talked a little on console yesterday about the fact that the EV crew members, Garrett and Mike, were probably not really taking much of a day off yesterday when they were supposed to be, because they'd be wanting to be focused for the spacewalk today. So I expect that the smaller amount of off-duty time that they'll get tomorrow, our spacewalkers for certain, and Piers as well, since his robotic duties will mostly be over at that point, are I think we won't have to encourage them too much to rest up, and then it's about time for Ken and Tony to start really focusing on everything they're going to need to do for the undock, the fly around, and landing. So I am confident that they will rest and relax. Maybe they take turns. Some of them got more relaxation yesterday, and some will get more relaxation tomorrow. In terms of the CETA cart, I am unaware of a specific need for the swing arm that is currently stuck on that starboard CETA cart. We were only using it in EVA 2 in order to get to that LDRI cable, so it wasn't even planned for use for us, and I haven't heard of any specific need for that. You heard of that?
The CETA carts are used, or a crew aid that's out there available for us, and so it would really be only used if we had failures that required us to go translate the large ORUs. It would be one of the tools available to us. So no baseline plans, but certainly if we had a specific failure, we would have that as one of the options for us.
And so on that, I mean, I think it's important to point out that's only one of 5 sockets for the foot restraints on that CETA cart, so it's by no means out of commission.
Okay, Tarek, did you have another question? I think that might have been it.
That's it, thank you.
Okay, and last on the line is Irene Klotz, please.
Thanks very much. Kirk, I just wanted to follow up something that you said about the station configuration with EVAs after the shuttle's not flying. What are you doing to manage the spacesuits? Can those be flown back and forth on the ATV or HTV, or you need to wait for the commercial crew to do those, and any other kind of tasks or activities that are going to be on hold for a while after the shuttle retirement? Thanks.
Sure. We went through, of course, when we decided that shuttle was retiring, we went through and looked at this problem, and our plan was to create, we call them megaplisses, but basically extend the life of the spacesuits on orbit without having to bring them home to be refurbished periodically. So now we have enough life on those spacesuits to take us through 2015, and we're working on plans to configure some more of those that could fly up and take us beyond 2015. And so that's what we're doing. Since we just got the go-ahead to extend here recently, we're still working through that. But our plan is not to fly them home. Of course, as you know, the ATV and Progress vehicles and HTV, all those are non-recoverable. The Dragon will have a capability to bring some mass home. Our focus of that is primarily payloads. There may be some additional mass above the payloads requirement, but we're not counting on that in this point in time for spacesuits. So it's really extending the life of the ones that we have on orbit, and we brought them home and basically reassembled them with brand new parts before we launched them to ISS, and we'll have a number of those on orbit to support us through the life after shuttle has retired.
Thank you. I know the spacesuits are put together in bits and pieces, but do you have some sort of cumulative number of spacesuits that are aboard? I know there may be like extra arm parts or glove parts for interchanging, but just in rough numbers.
I understand your question. Do you know, typically we have 3 on board ISS long term, but I wouldn't swear to that now. Maybe you know.
Yeah, actually, STS-132 brought up the 4th megapliss, the long duration pliss or spacesuit that was going up. So right now, that's the quantity I believe that we're planning to maintain as far as the life support pack. And then we do have a number of boots, arms, legs of different sizes. So there's an entire inventory of spacesuit parts up there now. So we can accommodate quite the range of crew members.
Thank you very much.
Okay, and we have a question here again.
Mark Crow, Aviation Week, and I had a look-ahead question. When you place the grapple fixture on the Russian segment, what access is that going to give you with the arm that you've not had before, or is that the point of it?
Having the grapple fixture on the FGB on Zarya gives us the capability to not only base the arm there, but it also gives the capability to I'll say park Dexter on that. So we'd have capability further back into the Russian segment. This will be the farthest aft grapple fixture we have. But like I said, it gives us another opportunity to park Dexter. Today we park Dexter on typically on the lab, on the nadir side of the lab, which is in view of one of our windows. So that's problematic for us long term, which is one of the reasons we were driving to do this. Or we put Dexter up on the MBS, which again, if you're doing operations like during a shuttle flight, typically we don't have it there. I think in this flight we had Dexter up there because we were adding the EOTP, but other flights typically we move Dexter down to the lab. So it just gives us additional flexibility. There's no driving requirement for reach aft in the Russian segment at this point in time, but certainly we would have that available to us.
And there's another question down here.
Peter Aylward, Southern FM from Australia. Mr. Sharman again. Could you explain the reason that the Soyuz 23 is launching and docking on the Russian segment, but then after docking it's translating around to the MRM-1? Is there a particular reason why it's not going directly there?
Sure. We talked a lot with respect to we talked to our Russian colleagues about that. The MRM-1 is not fully outfitted for an approaching vehicle in its normal autonomous mode. In other words, and the reason for that is it takes a spacewalk to go out and deploy targets and hook up cables so that all the antennas are functioning that we require for that autonomous mode of the Soyuz. And so what you have to be is flown manually. And so the Russians would prefer to, and in fact that's what we're doing, to fly up to the, let's see, I'll make sure I get the right port here. We are flying up to the service module aft port, and then it'll relocate to the MRM port, which is on the nadir side of Zarya. And that relocation is all flown manually. They back off, rotate around the ISS and dock. So that'll all be done manually. We'll do a Russian EVA this summer, and at that point in time, it'll be ready for fully automated dockings to that port in the future.
Any other questions here? Okay, to add to, again, one of the answers from before, the space station is complete by 93% of the mass for assembly. And also, there was a question maybe about the Soyuz launch and docking. If those were GMT times, it may be the 15th and 17th Central Time locally. Do you think? Okay. And coming up on NASA television, we'll be airing the videos that were retrieved from the solid rocket boosters for the first time. That will come up at the top of the hour. And the flight day highlights for today's activities will begin airing at 5 p.m. Central Time as the crews on board the shuttle and station are now in their sleep shift. And with that, we'll head back to Mission Control.
This is Mission Control Houston. Welcome back to live coverage of STS-132 from here in the Space Shuttle Flight Control Room. We want to remind you that coming up next year on NASA television,